Hey guys, welcome back to STR8CHEM. In this video, we're going to talk about pH and pOH. Let's start with the definition. So pH is defined as the negative logarithm of the concentration H+. H+, as we know, also known as hydronium ion H3O+. So you can use either one of them to define pH. This definition is also going to be important for your calculation because we can use it to calculate the value of pH of a solution. Whereas the definition for pOH is the negative logarithm of the concentration of hydroxides OH-. So you can guess now what sort of solution will be having OH-. Yes, you're right. It will be those basic solutions, and pH, H+ over here, would be those acidic solutions. But if you are able to find out the value of pOH of a basic solutions, we can use that value to find the value of pH as well. So that brings us to the first important point you need to know. pH, when you add that with the value of pOH of a solution, it will be equals to 14. So that's why I told you just now, when you are able to find out the value of pOH of a basic solutions, we would be able to find the pH value as well, because you can just simply plug in the value in here for the pOH, and you're going to move that to the other side, and thus you would be able to get the value of pH. This is also a very important point that you need to know, because we're going to use this a lot in the calculation. Important point number 2 is the pH and pOH, they are dimensionless quantities. That means they do not have units. Okay, so the value will stand as itself. So if you have pH equals to 7, it will be just 7 without any units. If you have pH equals to 5, it's just going to stand by itself. Now, important point number 3, at 25 degrees Celsius in pure water, we don't have acids nor base. The concentration of H+ will be 1.0 times 10 to the power of -7 molar. So now you can roughly imagine that your drinking water would have the concentration of H+ this much. But in the acidic solution, the concentration of H+, okay, the concentration of H+ over here would be more than 1.0 exponent -7. Therefore, the pH will be lower. Okay? And for basic solutions, the concentration of H+ will be lesser than 1.0 times 10 to the power of -7. And thus, the pH of basic solution would be bigger than 7. And for the neutral solution, the concentration of H+ will equal to 1.0 times 10 to the power of -7 molar, and the pH would be 7, which is your typical neutral pH.